Hello everyone, welcome to section 5.3, which concerns solving systems of equations using elimination. So we've covered graphing, we've covered substitution, so now we're covering the method of solving by eliminating one of the variables, and it's pretty cool. It's one of my favorites, so let's go ahead and get into it. So let's say here you have two equations, right? You have 2x plus y is equal to 7, x minus 2y is equal to 6. Actually, you know what? Let's do this one first here. So, sorry about that. So first of all, you see these two equations here. And what if I was to add these two equations together? So let's say here, I'm going to write it over here. So x plus y is equal to 10, and then x minus y is equal to 12. Now, if I add these two together, notice that this positive y and this negative y cancel out, right? And then this x and x add up to become 2x. The equal sign comes down, and then 10 plus 12 is going to be 22 today. So you get the equation 2x is equal to 22. So you just divide by 2 both sides of the equation, and you get x is equal to 11, okay? And then in order to solve for y, you could just plug it into any one of these. So I'll just do the first one. Looks easier. 11 plus y is equal to 10, and then subtract both sides by 11. And then we get y is equal to negative 1, okay? So that's your answer. Your answer will be, 11, negative 1. Okay, so first, what are the how-tos? So to solve a system of equation by elimination, we need to write the equations in standard form. So remember, what is standard form, first of all? Standard form, remember, it's ax plus by is equal to some constant, where a, b, and c are constants, okay? If any coefficients are fractions, clear them. What does it mean to clear them? It means multiply all the equation by the LCD, right? By the least common denominator of all the fractions. Okay. Then you make the opposites, the coefficients of one variable opposites, decide the variable that you eliminate. Then you add them and solve, and you substitute into the other one. So these steps seem pretty long, but as you saw, it's really actually not that bad. So let's go ahead and do another one. So here, this one, we have 2x plus y is equal to 5, x minus y is equal to 4. So also, just a side note, elimination in other textbooks is also known as adding or addition, the process of addition, so equations. So that's kind of interesting. So these are already opposites, these guys, so that I can just go ahead and add straight across. So that's 3x. These will cancel out. 1 minus 1 is 0. This is 9. Then solve for x. So x is equal to 3. And then plug that into here. Either one. 2 times 3 plus y is equal to 5. 6 plus y is equal to 5. Subtract. Solve for y. Y is equal to negative 1. And then your solution is 3, negative 1. Okay, so, but what if it's not that nice? So that's where we can go back to this one here. So here you have 2x plus y is equal to 7, and then x minus 2y is equal to 6. If I were to add them this way, I'm not going to eliminate any variable. Why not? Because the coefficients of the variables are not the same. So the goal is to eliminate one of them. So we need to change either one. We need to multiply either one of the equations so that we get opposite. So what I'm going to do is I'm going to multiply this top equation by 2. Why? Because I know that this is a minus here and there's a plus. So I'm going to get them to cancel each other out. I'm going to get the y's to cancel each other out. So let's go ahead and do that. So distributing along the top, I get 4x plus 2y is equal to 14. So notice I did all of it. Then I'm just going to rewrite the second equation underneath. And see, now they're exactly the same, but opposite, which is exactly what I want. Okay, so now I can go ahead and add. So this becomes 5x, and then this will cancel out. And then 14 plus 6 is 20. Okay, so you're basically combining them and then solving for x. divided by 5, x is equal to 4. So now to solve for y, I can plug into either one. This time I'm gonna plug into the second one. So 4 minus 2y is equal to 6, minus 4 minus 4. So then you get negative 2y is equal to 6 minus 4 is positive 2 today. Divide by negative 2. And then we get y is equal to negative 1. So that's it. So 4 comma negative 1. That's our solution. So not too bad, right? So I think we could do that. Let's see here. Let's do one with fractions. Or actually, let's see. What else could I do? Let's see. Let's try this one. Okay, now this one, there's not one step that we need to do. So they're both, you have a positive and you have a negative for the y's, but you notice that it's a 3y and a 2y. So what do? Well, we find the common multiple, yeah? Like, so that it'll cancel out. So where does 3 and 2? So you kind of, I'm going to draw a little thought bubble here, okay? So this is kind of like, this is like you thinking, you know, like, what am I thinking about? So I know that the multiples of 3 are 3 and 6. I know the multiples of 2 are 2, 4, and 6. So then I think, oh, okay, 6 is common. What do I need to multiply? Now I need to multiply the top and the bottom so that they cancel out. So I'm going to multiply the top by 2, and I'm going to multiply the bottom by 3, the bottom equation. So then that's going to give me, so for the first one, I'm going to distribute this 2, and I'm going to get 8x minus 6y is equal to 18. And then on the bottom, I'm going to distribute, for the bottom equation, I'm going to get 21x plus 6y is equal to negative 18. Okay, so then I'm going to add that together. That's going to cancel these, which is what I wanted. And I'm going to get a 21 plus 8, so that's 29x is equal to, actually, this also cancels out and becomes 0. Why didn't we write 0 on the left-hand side? Because it's arbitrary, it doesn't help us. But on the right-hand side, it's very important that you do write it because there's nothing else to have on that side of the equation. So anyway, yeah. So divide by the coefficient of x. X is equal to 0. Plug it into either one to solve for y. I'm going to plug it into the second one. So 7 times 0 plus 2y is equal to negative 6. That's canceled out. So then I just get 2y is equal to negative 6. Divide by 2. And y is equal to negative 3. And that's it. 0 comma negative 3 is my solution. Okay, let's do one with fractions because we love fractions, don't we? I know I do. Okay, so what if we decided to cancel out the x's this time? Okay, so what are some things we need to know? So things we need to know, right? So first we say, okay, we're canceling out the x. We want it to get where it's the opposite. So we want something like a positive and negative, right? That's kind of what we want. So how do we do that? So we can leave the top one the same, but for the bottom one, what if I multiply by the reciprocal, or at least clear the fractions? If I multiply by the reciprocal, will I clear all the fractions? No, I won't. So maybe I need to take 2 steps here. So first, let me go ahead and clear the top fractions and the bottom fractions. So what do I do to clear the top fractions? So for the top, I'm going to multiply everything by 2. Okay, so we're going to get 2x. And the first thing I'm going to do is clear fractions. So first thing, clear fractions. I'm going to kind of scaffold this a little bit. So then 2 times 1/2, that's just 1. Y is equal to 12, okay? And then on the bottom, I'm going to multiply everything by, so I have a 2 and I have a 3 and I have a 2. The LCD of that we saw earlier is a 6. So then I'm going to go ahead and multiply by 6 everything. So 6 times 3 halves, right? So that's going to be 9x. 6 times 3 halves, for those of you that are like, how the heck is that 9? 2 goes into 6, 3. 3 times 3 is 9. So 9x. And then 6 2/3 is going to be 4y. Okay. Remember, 6 times 2/3, right? This is 12 over 3, which is 4. Or you can do like that. Is equal to, and then 3 times 17 is going to be what? 3 times 17 is 51. Okay, so now what do we have here? Now we have something. So here on the bottom, we have 4 positive. So maybe in this case, it's actually better to change it to clear the y's now that we saw it, right? But there's a 4, so we want a positive 4 and a negative 4y. So, so what I'm going to do is I'm going to multiply the top by a negative 4y, and then I'm going to distribute that. So along the top, I'm going to have negative 8x minus 4y is equal to negative 48. And the bottom, I have 9x plus 4y is equal to 51. Then adding them together, right, this is going to cancel out. Negative 8 plus 9, that's just x. That's nice. And then negative 48 plus 51, that's 3. So x is equal to 3. So yay, we have one of them. Now let's solve for y. I'm going to put it into this equation up here, actually, because this is kind of easier. See how y is by itself here? That's easier than plugging into either one of the originals. And it's still valid because it's an equivalent equation. Okay, so 2 times 3 plus y is equal to 12. 6 plus y is equal to 12. 6 y is equal to 6. So we get the point 3 comma 6. All right, not too bad, yeah? So that's that one. Let's do a couple more examples just because examples are fun. Okay, so here we have solving the system using elimination. They both need to be in the form ax plus by is equal to c. So let me move this up just a tad. Okay, so so this one's in the right form, but this one is not. So let's go ahead and change that. So the top, I'm just going to write 3x plus 4y is equal to 12. And then the bottom, I'm going to add the 3/4 x to both sides. So I get 3/4 x plus y is equal to 3. So now looking at this, I'm going to multiply the bottom one by negative 4 because I want to get rid of this fraction and I want to change this to a negative. Okay, so let's go ahead and do that. I'm going to rewrite the top again. I'm going to write it over here. So 3x plus 4y is equal to 12. And then the second one, I'm going to distribute this negative 4. I'm going to get negative 3x minus 4y is equal to negative 12. Oh, that's interesting. What's happening? Okay, so let's go ahead and see what happens. This is very fun. Okay, so when I add them together, these will cancel. These will cancel. That's a 0 on the left-hand side. And then these cancel, and that's a 0. So when you get 0 is equal to 0, if you remember, what does that mean? That means, graphically speaking, it's the same line, right? You have the same line on top of each other, right? So that means that there's infinitely many solutions. Okay. Okay, so let's do another one. I think this is a similar one. Okay, so here, let's go ahead and try to eliminate the x. So let's multiply the second one by 3. So on the top, we get negative 6x plus 15y is equal to 10. That's the top equation. And then in the bottom, I'm distributing this 3. And I get 6x minus 15y is equal to negative 15. So now I'm going to go ahead and combine them. So negative 6 plus 6, that actually cancels out. 15y and negative 15y cancels out, so I get 0 on the left-hand side. 10 minus 15 is negative 5. Uh-oh, wait a minute. So what does that mean? That means that this doesn't make sense. So there is no solution. Okay, that's no solution. You probably have you have something like, parallel lines. You don't probably, that's what it is. Okay, so those are the possibilities. So the possibilities when you're solving, we already talked about this earlier, yeah? Where you can either have one solution, infinitely many, or no solutions, okay? When you're solving a system of 2 linear equations. Okay, so let's go ahead and do a word problem because we love word problems. The sum of 2 numbers is 42. So x plus y equals 42. Their difference is 8. X minus y is 8. Find the numbers. We're going to go ahead and eliminate the y because that's easiest. So 2x is equal to 50. Divide by 2, divide by 2. x is equal to 25. Plug it into the first one. 25 plus y is equal to 42 minus 25 minus 25. So y is equal to 17. Okay, and that's it. So if I add these together, I get 42, and if I subtract, I get 8. Okie dokie. So, so here's just some things, you know, when do you choose the most convenient method to solve a system of linear equations? So you can either do, they're not gonna tell you which method to use. Like later on, you know, if you stick with me, I probably will tell you, but I'll try not to tell you because you should kind of start getting to know how and why to use it. So if you need to see a picture, you graph, okay? If you see that one equation is already solved for another, substitution might be easier. And then elimination is when both of the equations are in standard form. So this one, let's not solve these, but just go ahead and just think which one would be easier to use, which method, graphing, substitution, or elimination. So for A, they're already both in standard form, so that would be elimination. And theoretically, you could use elimination all the time. That's fine. Like, I'm not going to get mad at you. Nobody's going to get mad at you. Nobody's going to go, hey, why did you use elimination instead of substitution? Nobody's, you know what I mean? Like, we don't have that much time. But this is just to help you. So here for B, notice that y is already solved in terms of x, and you could just plug it in. So this one, you could use substitution. Substitution is spelled like this. Okay. All right. And that's it for 5.3. So remember, you can do odd or every other odd. Good luck. Happy studying. And I will see you in the next video.